How does passive cooling work in unexpected places? Imagine a building in the middle of a desert or a remote mountain village where there's no electricity to run air conditioners. How do people keep cool in such places? The secret lies in natural heat transfer methods that don't need power. Passive cooling uses sunlight, air, and water to lower temperatures naturally. It's like giving the environment a helping hand to stay comfortable. One key method is radiative cooling. This involves surfaces designed to reflected sunlight and emit heat into space. These surfaces are coated with special materials that bounce sunlight away and radiate infrared energy through the atmospheric window, which is a range of wavelengths between 8 and 13 micrometers. This allows the surface to cool down even during the day, sometimes below the temperature of the surrounding air. Think of a rooftop painted with reflective paint that also emits heat at night, cooling the building naturally. Another way is evaporative cooling. When water evaporates, it absorbs heat from the air around it. In hot, dry climates, wind catchers or architectural features like water pools and wet, porous materials can direct airflow over water, cooling the air before it enters a building. Modern systems use misting or wet cellulose pads to do the same without fans. This method is simple, cost-effective, and works well in areas where humidity isn't too high. Thermal insulation and smart design also play a big role. Thick walls made from adobe or mud brick absorb heat during the day and slowly releases it at night. Building layouts that maximize shade, like narrow streets or overhangs, block direct sunlight and keep interiors cooler. These strategies have been used for centuries in ancient civilizations and still work today. In unexpected places like off-grid cabins, humid tropical villages, or even temporary shelters, combining these methods creates effective passive cooling systems. For example, a small home might have reflective roofing, thick insulated walls, and a water feature outside. This setup can reduce indoor temperatures by about 9 degrees Celsius or around 17 degrees Fahrenheit without any electricity. That's enough to make food last longer and keep people comfortable. Mechanical engineers can design buildings with high solar reflectance and infrared emission surfaces to boost radiative cooling. They can incorporate water features or evaporative pads into architectural plans or mechanical systems. Using thermal mass and insulation strategically helps moderate indoor temperatures. Hybrid systems that combine radiative and evaporative cooling can cut down on energy use and reduce reliance on power-hungry air conditioners. Understanding these natural cooling methods allows us to create sustainable solutions for environments where conventional air conditioning isn't practical. It's about working with nature's heat transfer processes to keep spaces comfortable, even in the most unexpected places.